Since most of our users are in dentistry, and the stationary scanner mainly scan models and impressions, I will explain the required functions specifically. Firstly, I'd like to divide the functions into 4 parts: impression scan, separated model scan, bite scan, single piece scan. The significance of impression scan is that it could save the plaster model procedure. Now, I will make the demo from the most basic single impression for this one. Firstly, new project. Please note the scan workflow is based on the physical materials you have. Select the single impression and click Start Scan. Fix the impression on. Then click Scan. The scanner executes 21 scans to fully fill in. After the scan finished, trim it. The middle mouse key flipped it to the opposite. The yellow parts are auxiliary. The opposite areas are the data we want. Select the area we want. Reverse selection and delete until it gets clean and complete. Then click Next to match the points. The matching will take time, depend on your PC's configuration. After matched in STL, the scan procedure is OK. Next, we text another single impression. It's deeper and more complex. How we act? Let's go. New project, single impression, start scan, fix on. Scan, and the same 21 scans when it finished. Obviously, there are holes not filled. Then we need Add Scan. Click the icon and then click. It will automatically add scan, but we must know the angle. The missing part needs to confront the scanner camera. Normally, no matter how complex the target is, we only need 5 to 6 add scans on top. Now, it's done. Middle mouse key flip the data, select the parts we want, reverse and delete until the data is clean. For this exception impression, the stripe light can't scan to the certain corner, thus there are holes left. But it's not the scanner's reason, since we all know technology is not almighty. The holes could be filled by curvature meshing. It's the final output as we could see. For the exception examples, handheld scanner could perfectly handle it. The stationary device indeed have the limit to scan very deep areas. Next, let's try the bite impressions. Dentists are quite familiar with it. The difference from the last impression is the bite relationship. Then we create a project. Select occlusion impression, as we could recognize the similar examples from the pictures. It indicates the solution the scanner could provide. Then click Start Scan. Look the notice here. It says scan the upper jaw and lower jaw. Actually, for the tripod tray, it means one side and the opposite side. Never confused. Just put the target on and click Scan. After 21 scans, trim, flip, and paint or select the area we want. Reverse and delete until it's clean and complete. Then the opposite side, the same operation. After both sides done, click Next. It will execute feature align automatically and successfully. If not, we could align the two sides by mark align. Then we click Next. The data will be wrapped in STL. Output a pair of data with occlusion relationship. We could input to ExoCAD or third party for design. Then we get the next type of impression, wax-up bite impression. Different from the tripod tray aligned by the joint parts, the two impressions should be aligned by the bite record. For this type, the procedure is that, firstly, we scan the bites, then upper impression, next lower impression, then align the two impressions by the bites records automatically and mesh. It's the main impression cases we meet. For the registered jaw impression, we will reflect in another video. Now, we go for the next function, separated model scan, or we call it die scan, which offers the single teeth modeling with location relationship. The reason why we call it separated model is that some single bits could be pulled out. To scan the model in my hand, since it's a single model, we create project. Select single, separated, then the bit selection will be required. Left click to select the teeth correspondingly and start scan. Fix the model and click scan. When it executes 9 scans and global registered, trim to clean, someone may wonder why the data looks so noisy. If I zoom in, we will find that's because too many points. Click Next. Mark the teeth as notice. No strictly requires on the teeth position. Any location will do as long as the marks on that teeth. Then go forward. The system will ask for die scan. Then we put out the two and fix both on the die plate. Please pay special attention to the location it indicates. Keep the teeth laid right. After the teeth fix well, put the plate on, then click Scan. After 9 scans done, trim it to clean, then Next. The two single teeth will align automatically with the previous denture. If not good, we could do manual align also, which require over 4 marks left clicked on the same position for the both. Obviously, the model aligned quite good. We just click Next. It will go for meshing. Output STL data finally. The two single teeth together with the denture is the data we need for design. Now, the single separated model is finished. What if the models with bite relationship and more separated teeth? Don't worry, our software also can handle well. But more teeth are, more cautious we should keep the bits right. Firstly, we should scan the bite. Create a project. Select bite separated model. We will find 2 types below. Click the left one to enter procedure this time. Later, I will explain the right one. Start scan. 3 scans in all. Then take part. Scan the upper jaw. Then scan the lower jaw. Every time we finish the scan, the system will ask for bits. As dentist, it's just essential job. Please don't make it wrong, or it will result in problem alignment. we will get a pair of dentures modeling located in the bite position. For separated model scan, if there are bite location, we fetch the bite record firstly. If only a single denture, we scan the denture firstly. But the following procedure should be die scan. This time, there are 6 bits in all. Also, we should fix every bit correctly as the yellow parts indicates. When we fix the tooth, please make it stand vertically. After fix them well, put the plate on and click Next. After 15 scans done, trim and click Next. Then we could see the moves, how the 6 tooths belong to where they were. Next, click for meshing. The whole process is completed. After bite scan, upper scan, lower scan, die scan, 4 steps that we get the 6 single teeth. A little time consuming, but the procedure makes very strict alignment. For the users want more efficient, we could all-in-one scan. That's to say, we could align all tooth bits only by bite record, skipping the upper and lower jaw scan steps. This time, we click bite separated all-in-one and start scan. Fix the bite's denture on and scan. After 9 scans done, we mark the single bit one by one as notice indicates. Then we fix all in one plate. Of course, the bits could be fixed randomly. Only the condition that the bits should keep in line. Next, after 15 scans done, mark again the bits correctly. However, in this step, if you failed recognizing which is which, just try to make sure as right as possible. Because if we failed aligning later, we could manually align as remedial action. Click Next. The bits are aligned on the track of bite records. Unfortunately, there are 2 bits failed due to lacking overlap parts. Then we go to manual align. Left click 4 marks on the same positions and fuse. Then we noticed it belonged well. Then next one, the same operation. Yes, the bits 35 and 36 are mixed up. I made a mistake when marked on the bits record, but it will not affect the final output. That's all the separated model operations. For single bit scan, the scanner precision is very important. If not accurate enough, the crown design based on the output STL can't fit. Luckily, our scanner is quite qualified with within 20 mm accuracy. The third part is for the occlusion scan. If we only scan the occlusion, most of the time we just need to do the orthodontics. The procedure is very easy. Scan the occlusion, scan the upper jaw, scan the lower jaw, then merge the both jaw by the bite location.
If you have this base type, fix it directly. If not, we need rubber band to fix firstly. Someone asked the articulator. Yes, we could scan the articulator too. I will demo it later. A new project. Select byte non-separated model and start scan. After 3 scans done, trim it and click Next. Then upper jaw scan. And lower jaw scan. Then click Next to automatically align. Then click Next for meshing and finish. Now, let's talk about the articulator, which stands for higher demand for occlusion, or just required to keep the existing oral-bite relationship for further design. To scan it, create a project, select Byte Articulator, click Start Scan. Then we noticed that the swing arm turning aside, leaving room for the articulator. Click Scan. It will execute 1 scan. Yes, DT300 is a very compact and integrated scanner. Can't support the articulator turning on the turnable. 1 scan could meet some users require, but not all the users. It all depends whether the 1 scan could get as many features as it could. For this model, 1 scan is quite good. Then we scan the upper jaw. The lower jaw. And the line. If not successful, we could easily align the bows by marks. Then click Next for meshing. The scan is done. That's the whole demonstration of the occlusion scan. Lastly, the single piece scan. If you just need to scan a denture, a false tooth, a template implants, use this function. Very useful and powerful. A new project. Select single, non-separated and start scan. After 9 scans done, if you want to add scan to finish, click Add Scan icon and add scan. Please confirm the missing parts to the scanner camera. Or you mark the missing part and add scan. Every mark will lead to the 6 scans around the missing area to fully filled. Since we marked 3, then it will lead 18 scans and finished. If don't want to add scan, reposition the denture and click scan. It will automatically execute another group modeling. Then we merge the 2 groups either by auto-align or mark-align. Then mesh it. Now we could see how good the output is. Also, we could scan multi-piece. Please note that the physical model material is very important. If it's too shining or reflective, the output will be noisy. we could make spray for this material.
Next, we scan a ring for the resolution test and a gauge for accuracy test.
For this 2.5 cm sized ring, we could get a watertight modeling with 0.1 mm resolution. It means that the scanner could handle 2 cm sized object scanned perfectly. The gauge The gauge, with a diameter of 2 cm, we measured in geometric result as 20.07 mm, so we could conduct the dental scanner volume accuracy within 0.1 mm accuracy. Thunk3D DT300 will release more functions soon. Welcome to follow us on www.thunk3d.com for more information.